Sorry about that. So basically today, when we talk about deep learning, we talk about a mathematical representation of human brain and neurons in particular. So neurons are just basically cells in your brain that activate depending on the signals that they receive. And if this signal is above a certain threshold, they fire to the next neuron. And these neurons together firing will cause a pathway or a neural pathway that creates basically the neural pathway that helps you learn a skill. So for example, when you learn a programming language, or you learn to play with piano, or you learn like a mechanical engineering concept, these are specific neurons in your brain firing, creating certain pathways that like solidifies that skill in your brain and in that specific set of knowledge or skills. This can be modeled mathematically with a bit of a simplification using the mathematical model on the right, where you take a series of inputs multiplying by the set of weights, then you sum them together and apply an activation function on top to introduce non-linearity to the model. And when you connect these neurons together, you get these neural networks that can achieve outputs that are basically it's because of the interactions of these neurons, and these outputs are quite complex. So the way it works is when data flows from one side of the neural network to the other side, the neural network starts learning patterns in the data, from the basic patterns at the near the input layers all the way to the more complex patterns and the decision-making abilities at the output layer. So a neural network normally is just constructed by connecting all of these neurons together. So when you connect layers of neurons together, you end up with a neural network. And neural networks normally consist of a series of layers. Three of them that are we classify those layers as are input layers, hidden layers, and output layers. So any layers in between are hidden layers, and any layers at the beginning and at the end are input and output layers. So what these neural networks do, because of the way they work mathematically under the hood, they learn the patterns in the data. That's basically what they do. So you don't need to tell them anything. You just design the architecture of the neural network. You pass your data through them, and the network figures out itself by adjusting its weights and biases to basically connect the patterns in the input data to the patterns in the output that you expect from the network. So for example, in this picture, in this example on the slide, we want this network to predict who this person is. So what the network is doing is, as the picture is basically going through the network from left to right, the network is learning simple patterns in the data, such as, for example, the edges, vertical edges, horizontal edges, diagonal edges, and then it combines the edges together into patterns like shape of an eye, shape of a nose, shape of a face. And then those then get combined together into understanding visual patterns of what, like, for example, George Washington's face looks like, or what Obama's face looks like. And this specific property, you can also use it on any other application. Any other application that you have imagery data, for example, in a manufacturing environment, you can help it to learn patterns in defects of products. And then once it learns those patterns, you can then use it to identify if there is any faulty items on the product line, as long as you have enough data for it to learn those patterns. So as you go deeper into the neural network, the network starts learning more complex patterns built on top of the patterns that it learned from the previous layers. The thing here is, these neural networks, especially the bigger they get and the more complex the architectures become, they are like mathematical black boxes. Basically, they're just like a function, but they are such a complex function that you don't know what it's doing under the hood. You don't know how the data is being wrangled and how the mathematics work inside these neural networks for us to fully understand what's happening. And sometimes the outputs make you feel like you're getting a good model, but that model, when you put it into the actual real-world scenario, may not perform as well. So even though it performs well in the testing scenarios, it may not perform well in the actual real-world scenarios because it's such a black box. And that's what is causing the ethical issues. So when it comes to AI ethics itself, one thing I want to talk about is the ethics itself is very important because of four main reasons. So in engineering, we were always really concerned about ethics. It's actually one of the main competencies of engineers. Like competency E of UK Spec is all about ethics, safety, and sustainability. The reason is engineers, if they make a mistake, a bridge can break, a building could fall down, there could be a train crash, lives could be lost. So it's very important that we are all ethical, and it ensures when we are ethical, as part of it, we ensure the safety of anyone who's going to be interacting with what we build. The other thing is when we are ethical about our profession, it upholds public opinion and reputation of the engineering profession. And because of that, any business that upholds that professional opinion gets more business, because people and companies trust people and other companies that are ethical and they do things by the book. And because of that, it's also good for business. So it's one of the main reasons why we should be ethical. And the other thing is it promotes sustainability. So when we consider all the aspects of what we're building, from the sustainability, environmental aspects, and from anything else, we help advance the engineering profession and all the aspects of it, also at the same time making sure that we keep the environment in the same place that we left it, whilst at the same time we're providing value to the society. So because of these 4 items, ethics is very important, and it matters that everything we do is ethical, including any innovative projects that we work on. And some of these projects may include adopting AI. So we need to be also worried about the ethics and the safety of any AI system that we build because of these 4 reasons. However, it is actually quite hard to do that. So because of all of these reasons on the slide today, it's very hard to implement AI ethics and to follow these principles. So let me start from top left all the way to the bottom right and explain them why. So one of the main reasons it's hard to perform AI ethics is because of data bias and quality. So every data set is different, and some of the data sets that you will collect, or field measurements that you collect from real world scenarios, could have bias in them. And bias could also be introduced by all sorts of variety of places, with a variety of factors. It could be introduced by algorithms that you use. The bias could be introduced by the fact that there is bias already in the real world environment that you're collecting data from. You may inadvertently include bias by the way you sample your data for your modeling techniques. And the quality of your data may not be good enough to build an AI model on top. And because of that, there is always data and bias and quality issues that will be present that will prevent you from building AI models and AI systems that perform well and in an unbiased matter. So because of that, it's very hard. The second one is the system complexity. So neural networks are a complex system just because a neuron by itself is easy to understand. However, when neurons connect together and interact with each other, especially if the architectures of these neural networks are complex, they create emergent properties. So these are properties that doesn't exist by their individual components alone. They exist because of the interaction between these individual components. And because of that, it's very important to understand what our AI models are doing layer by layer and understand the mathematics inside these models. And there are actually lots of movements around AI explainability and transparency when it comes to building AI systems. And that's why it makes it complex. The other thing is lack of understanding of what the problem is. So if you don't understand what your problem you're solving, you may end up choosing wrong evaluation metrics and testing metrics on your models. When you do that, you think that your model is 99% accurate, and you basically put your model into a real-world environment, whereas in the real-world environment, it may not perform at that level because that metric that you used to evaluate your model was not the right metric. So it comes down to the understanding of the metrics that you can use to evaluate your models at the end and test them versus the problem that you're trying to solve. And we will have an example on this in one of our case studies to help this understand a bit better. The other bit that makes it difficult is unintended consequences. So you may build something, but then put it into a real world scenario to start using it, and you've never considered how people, because better algorithms now exist, and those new algorithms may not necessarily be the best still, but they could have their own implications when you use them. So you have to understand them again. That makes it really hard as well to comply with AI ethics. There is pressure to race to the market. So you want to release your models, but at the same time, you want to be ethical. But there is this pressure to release the models on time so that you're a bit faster than your competition. And that may cause ethical issues and ethical concerns. There's always trade-offs, dilemmas between requirements and stakeholder needs, as well as issues around understanding and interpretability of what you're building. So it's hard to explain to the business why an AI model is working the way it is, just because of the same thing I mentioned, because of the system complexity and the fact that it's quite hard to understand how the model is making those decisions. How is it taking the data, learning patterns in it, and then making a decision based on those learned patterns at the output layers? When we talk about deep learning, for example. So it makes it quite difficult because of that to understand what it's doing. And there are lots of new frameworks and techniques that came out, XAI, explainable AI, and like all the other frameworks, tools that allows us to now debug our neural networks and our AI models at like lower levels. But still, it's still an area in development. And if you don't really understand fully how our black box models are working in our testing area, we should be very concerned, and we should always be very cautious how we start using them in real world scenarios. The other issues are variations in cultural expectations. So this is a bit hard to provide examples for, but some outputs from AI models may not necessarily cause concern in certain cultures, whereas in other cultures, it may be very sensitive. Normally, things to do with racial issues and things like that come into play here, but it could also be applied to engineering. So how it performs in engineering context in different cultures and different countries may have different implications. So you always need to make sure that, like, even if they're performing well, the cultural expectations do also align with what the objectives of the organization are in relation to performance of these innovative AI systems that we're going to be building. Another issue, lack of standards, regulations, and processes. Pretty much most of engineering projects these days have lots of standards. So you always have standards you can follow. It's part of the requirements of projects. It's well understood. You can just follow them. And it's basically, if you've done it, you're kind of sure that it's going well. But if you've not done it, then like you need to do it. And basically projects don't go into an actual production environment without those standards having been met. However, the problem is we don't have those in AI. And because of this problem, because of these reasons I've mentioned, it's hard to build the standards. There's just not enough examples. There is not enough data and past experiences versus other engineering sectors where we have things to base our frameworks on and standards on. And because of this, still, like, it's quite hard for the legal systems and for regulation systems to catch up with the advancements of the technology that's coming in. If someone starts building a standard for long short-term memory networks, now that the ChatGPT LLMs are out, large language models, all of those should go out of the water because people now start using ChatGPT technologies instead of LSTM technologies, for example. Lastly, it's accountability and responsibility. Sometimes it's hard to define responsibilities and accountabilities in projects, AI projects, between engineering teams, policymakers, developers, and business stakeholders. If something goes wrong, it's kind of hard to understand who is responsible for it. Like, who must sign off a set of outputs and deliverables on an AI project, because these are novel projects and their scoping might be different compared to traditional software or traditional engineering projects. It's also hard to define accountability and responsibility demarcation points. And because of these, it makes it quite difficult to comply with AI ethics. And that's what makes the problem really hard. So we do have a quite, so Dan has a poll for us to do because on these. What we want to do is understand what you think is the most important issues around AI ethics based on these elements. So Dan, if you can share the poll, then we can have a chat about what everyone thinks are the most pressing matters when it comes to building AI systems in engineering.
Okay. Yeah, thanks, Ali. I think we're just going to get it set up and it should be landing onto your screens right about now. We'll just give it a few more seconds so we can gather these poll results, and then we'll post them. Okay, let's get the results. And Ali, can you see these results now appearing? Just if not, I'll read them out to you.
Okay, I can see the results. Maybe publish them to the audience as well so they can see them.
Yep, I've published them. They should be able to see them as well.
Excellent. Wow, so this is a very interesting pie chart. Pretty much it's like a quadrant. So we've got lack of standards and regulations at the biggest, 33%, bias and data quality issues at 22%, system complexity at 21.5%, and then lack of clear processes at 23%. So it's pretty much all across the board with lack of standards and regulations at the highest, and then technical issues, which is the red and yellow, bias and system complexity, they take the other half of the pie chart. So I think based on this, the problem is very complex, just because it's all over it's both across the technical side and the commercial sides and non-technical sides that makes it very difficult to understand the AI ethics. So I think with the standards and regulations, it also the fact that they're hard to produce and there is not many of them is because of the technical side. So the more people understand how AI works and the more people understand how the neural networks works, the more people can help with building the standards. There are already efforts under the way, but when the standards come, they would provide the frameworks and they make it much easier to tackle these problems as organizations. However, because there are not a lot of innovative projects on AI in existence, and because of these technologies are so complex and they're just moving so fast, it makes it really difficult. So it was really good understanding that like this chart is kind of like into a quadrant right now, and understanding of how everything works. So with that said, let's do a couple of exercises. So I think just talking about the AI ethics might be a bit not very engaging. So I think what would be interesting is I'm going to present a couple of scenarios of engineering companies applying AI. Just to disclaim this one. So this one is this is a technical understanding of what time series data is and why it's a problem. I mean, to some extent, I'm giving you the answer on the picture. But what is the implication here if they do it this way? So they just basically, let's say the engineer on the project, they follow the tutorial online, and they just follow the tutorial to the T on their time series data. The tutorial is using structured data, tabular data, or something else. It's not time series. There is no time. So Antonio says there's going to be leakage, but why? Why is there going to be leakage? Like, what is exactly happening? And what happens if you do a random split of the data into a training set and testing set? So let's say you have a table of data, some rows. It's sorted by date. So it's sorted by date time. So you have a column that has date on it, and you sort the data by date. Let's say temperature over time, right? So like you're predicting weather patterns, and you're trying to predict the temperature of the weather. It's a time series data. You then basically shuffle the rows, and then you pick some rows randomly for training, and then you pick some rows randomly for testing. So this one is more like a technical understanding issue of how time series data works. So SARP says effective time on the data not mitigated for. Not a realistic data set. Any other ideas? Validity of the sample. Okay, so this one is quite hard. You end up ignoring the wider context surrounding the data. Any other ideas? No constants in the data used. Giving AI the answers by doing the random split. One of these is correct. Anyone guess which one of those answers are correct? Effect of time on data, not the realistic data, validity of the sample. You end up ignoring the wider context, giving AI the answers, no validation before deployment, no constancy in the data used. So Jonathan, well done. That's the answer. You've given the model the answer. It has the future info of the training data. So when it comes to using time series data, you have two different ways that you can split your data set into a training set and a test set. So the process is you train your model with a training set, and then you test it on the test set to make sure it works. The problem here is because you have a time series data, your data is ordered by time. When you do a random split, you have some future data and some past data mixed together, and you give it to the model. The model learns the future patterns. It's like asking someone to predict the future, but telling them what the future is. So what you need to do is you need to split your data using the temporal spirit. So you completely take a piece of future, you hide it from the model completely. That's your test set. And then you train your, and then whatever is left is the historical data. So the demarcation point in the first, so in the temporal split, if you look at the diagram where the blue meets the orange, that's the demarcation point. Let's say that's the present time. Anything before that is historical. Anything before that is future. Anything after that is the future. You should only give the historical time to the model to train. If you start mixing the future with the past in this context, what ends up happening is that it will perform poorly when you apply to the real world, because on your tests, even you've chosen the metrics correctly, you made sure there is no bias, you've done all this stuff. What happens is you're leaking information from future into the past. And this leakage is called a temporal leakage. And because of the temporal leakage, the model kind of is seeing the future. So if you've seen the future, you can predict it. If I see what happens tomorrow, I can tell you what happens tomorrow. You've trained me to tell you what happens tomorrow. It's just basically giving them someone and watch, and then they just tell you what happens tomorrow. So the way you this comes down from a lack of understanding of how time series data work and how does it apply to the process of building AI models. So a data scientist or an engineer who's building AI tools, they need to understand this phenomenon. The fact that when they're working with time series data, they need to make sure that when they're splitting their data into random training set and a test set, they can't do that with the time series data because the information from the future could leak into the past. And that's like one of the other reasons it could cause ethical issues, because your testing and your other processes may, you may skip through them because you're getting good results back. So every time your model is performing really well, 99%, 100%, there is something wrong. Most of the time, there is something wrong. It's not that your model has learned perfectly. There is something wrong with your process. You need to go back and look. And if you just trust your model performing at 100%, there is something you probably have missed, either some correlation or co-correlation in the data that you've not looked for. The model somehow managed to, cheat and understand the exam questions and answer to exam questions, or that you're giving them the answers inadvertently or unconsciously by doing this kind of work. One last example, and then I think that would be the end of it. Here, an engineering company needs labeled CCTV data to train a computer vision model for counting people. So like something like that on the right. They've got a line of judgment. They've trained the model to detect people and then track them. So each person gets a dot on them, and then that dot has an ID. And then if that dot goes past the line of judgment in a certain direction, they can then count someone as entering or exiting a vehicle, for example, a train, or here a building. But what they do is most of the time when you're building AI tools, you have to basically label your data so that your AI can then learn from that data using those labels. So often this is a very tedious process and it's very expensive. If you try to do it, for example, in the UK, it may end up being very expensive. So what normally some companies do, they send this data to others overseas countries at a cheaper price to label them. So what they do is they just simply share this data to an overseas company for labeling, but they don't follow any kind of GDPR rules or anything like that. What is the implications here? I mean, this is quite easy. If you don't follow GDPR, you are basically just giving your, let's say this is a CCTV data. This is basically sensitive data. It's called PII information in it, personally identifiable information. So what happens is when you send this to an overseas company to label, you could end up with a financial lawsuit because, for example, I'm just giving a very exaggerated example. Let's say we have some refugees that come here from another country to the UK, and then you have some CCTV data of them. You send this data to a company in the country that they fled from, and this data gets into the government's hands of that country, and then they can start hunting them down. They know now where these refugees are, and they can hunt them down. That's like one implication. Other implication is this data could get into the public. It could be like passport information. I don't know. It could be any kind of information gets into the public, and it could cause lawsuits, and it could cause privacy violations and destruction of trust. So all of these still apply, and you need to make sure that when you share data with third parties, you follow guidelines and rules. And even if your data is sitting in UK servers, if you're sending them across the borders, you need to make sure you're following rules and you have actual security practices in place. So that's like another reason like AI ethics come into play. So there are actually solutions to this that we're going to go over quickly. So there are 3 different frameworks that have come into play that allows us to go over like these various scenarios and make sure that we are applying them correctly. Microsoft has put together a framework for what's the 6 principles that are important when it comes to applying AI models: fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. So making sure that there is no bias in your data, making sure that it can perform reliably and safely. So you have enough processes in place to make sure it catches those issues. Same thing with privacy and security. So you're not sharing PII data without proper processes in place. Inclusiveness. So AI systems should empower everyone to engage people. So you actually make sure when you collect data, you collect enough data of everyone and make sure there is no bias in it. Making sure that you can actually explain the decisions your AI models are making. You have transparent systems in place for describing how you built it so others can review, and so things can get peer-reviewed, and you have accountability. If things go wrong, there are actually certain people that are accountable for these AI systems. And the mathematics work under the hood. When we're building AI tools, any AI model is basically, it's a mathematical function. So as long as you can define your problem as a mathematical problem, you can build an AI model for it. But often if your problem is very complex, so for example, I don't know, identifying a cat from a dog is still a very complex problem because under the hood, computers don't see pictures the way we do. They see just numbers. And it's because of the fact that these numbers get crunched so many times at such a high level dimensionality, it makes it really hard to understand what's going on mathematically under the hood. So you can just see a loss function or some metric is going down, like your loss is going down, but you don't understand why it's going down. Like, what is it exactly that the model is learning? And that's why like there is so much research is going on into explainable AI tools to help us understand different layers of the neural network, what's happening in each one.
Fantastic. Thank you, Ali. Yeah, we definitely have got some fascinating questions here. Another one, quite interesting one here. I'm not sure if you can help here. This is from William Dew. Will the AI field propose laws similar to the 3 laws of robotics?
I think, yeah, I think I'm not aware of those 3 laws of robotics. So I can have a look and come back to you on that question.
That's okay. Thank you. This is from Thomas Reeves. What additional skills do you think we need in our organizations to learn to manage and accept the outputs from these AI systems?
So there is a mixture of commercial and technical skills that might be required. Part of the AI for Engineers course, we're going to talk about building AI capability in organizations. And there is a whole session on it when it comes to scoping AI projects. Part of this is you definitely, if you're going to be building anything that's very custom or like a proper system, you can use no-code tools to build AI models these days. However, if you want to build anything that is actually proper, real-world scenarios, you will need to write programs. You will need to write and most of the time in Python, and you need to use deep learning frameworks that are written in Python. And it's more about understanding like of all the data science terms and the data science concepts, statistics, and mathematics. So how these algorithms that you're using are crunching the numbers. Because if you don't understand statistics, you will end up with those pitfalls we just mentioned today. So you need to understand the whole process of how AI models are built and how the mathematics work. And there are some software engineering bits that you will need to know that the organization needs, as well as commercials such as intellectual property. Whose intellectual property will their models will be? Like, what if the data you use is not yours? It's the client's data. So there are always like complex bits around it that you will need. But oftentimes the technical team, you will require engineers who understand the data. You will require programmers who can write in Python. This could be engineers as well. And you will need project managers who understand agile projects, because oftentimes these projects are more iterative. They need to go back and forth to progress. Sometimes you may not be able to implement it in a waterfall manner. And you will need commercial people with experience in AI on the commercial side, so that they can sell, they can gather data for these AI projects, and they can support these projects.
Sorry, Ali, I was talking. I hadn't unmuted myself. I was just going to say, we're coming sort of very close, conscious of time here, because a lot of people will probably be finishing and off their lunch breaks, etc. So we haven't got to get around time to answer all the questions, but we'll have them recorded, and we'll get them feed them to you, Ali, and we'll be able to respond back to everybody who has asked a question. So. Yep. Which is good. Thank you again to Phil Saunderson. He's just put actually into the chat box the 3 laws of robotics there. So someone's actually given a bit of guidance. I'll give you one more question then, Ali. This is from Lee Alexander. AI seems to be a tool for large companies. How will SMEs take advantage of AI? Could large companies start to reduce outsourcing if they can themselves be more efficient using AI?
So large companies has an advantage is because they can hire the capability or they can subcontract to smaller companies, and they have the money to do so. Small companies can still compete, and I still think small companies also have an advantage of the fact that they can move really fast, versus large companies has so much like hoops to jump through before they can implement and adopt AI. Because if something goes wrong with large companies, they have like a lot of things they need to cover. Whereas with small companies, they can fail, they can have different mistakes, and they can go through it faster, as long as they're still ethical. But what I'm saying is that smaller companies can skill up digitally on the AI side internally, without having to spend a lot of money hiring the talent. They can actually upskill the talent internally, upskill the staff. And they also have an advantage of having access to certain data sets that large companies may not have. This could be intellectual property of the small company, and they could use those to build AI models, which also then